Welcome to day 2 class of Base SAS training. In today's class, we'll be learning about data mining. The concept of data mining means data is present in your system. We'll be learning how to mine that information and retrieve results which is required for our research report. In data mining, we'll be learning about conditions. We'll be using if condition, where condition, if condition, then action, else condition, do command, as well as else do command. We'll also be looking at mnemonic symbols such as equal to we can write EQ, less than we can write LT, greater than we can write GT, greater than equal to we can write GE, and many more which you can learn from the Little SAS book. Then we'll learn how to create libraries in SAS, how to see all SAS files in a library, which means how to read the contents of all the SAS files in a library. Then we'll learn how to delete a dataset in a library and how to delete every dataset in a library. So we'll start our day today. First of all, we'll go to the learning materials. So here I am in the learning materials. So I'll go to codes. I'll open SAS training. I'll open basic. I'll open day 1, day 2 codes. These are all the codes we'll be working on today. So what I'll do is I'll Control A to select all these codes. You can either Control C or right click and copy all these codes, and we'll paste all these codes in the program editor in the SAS software. So I'll go ahead and open the software now. So here I've opened the SAS software. So I'll click on program editor. I'll paste all the codes here. To paste all the codes, you can just Control V and paste all the codes here. So all the shortcuts that you normally use with your normal computers, they are all applicable here and SAS as well. You can use them. So these codes that we'll be working on today, these are majorly for data mining. The concept of data mining means data is present in your system. You have to mine that information and retrieve results which is required for your research report. It is the very first step which is used by any researcher working in an organization. First they mine the data, they make it usable, and then further they start researching on it. So we'll start working on all these codes here today. So first of all, if you remember, we have a data in the SAS user library by the name admin. So we'll be working on that data. So we said that if you want to work on any data, first of all, we'll create a copy of that data. So we'll do that. We'll create a copy of this admin data in the work library. You can give any name to the data as long as it follows the rules, which is 1 to 32 characters, can have an underscore, cannot start with a number, cannot have spaces, and cannot have special characters. So we'll just give the name admin. So I'll read this command here. Data work.admit semicolon set SAS user.admit semicolon run semicolon. I'll run this command. Now we'll check the log window. The log says there were 21 observations read from the dataset SAS user.admit. The dataset work.admit has 21 observations and 9 variables. So this is basically saying that it has read 21 observations from the dataset SAS user.admit. It has created the data in the work library by the name admit. This data has 21 observations and 9 variables. So we'll open libraries. We'll open work library. Now we have this admit data here. We'll open admit data here. Now that we have created a copy of this admit data, we'll be working on this data to learn about different data mining techniques. So now let's imagine that you're working in your organization and you're working with different teams here. So now in this data here, if you see, we have this variable sex, we have M and F, which means we have male and female in this data. Now let's say your team now has to work on only males data only. So we'll do data mining here. We will only retrieve data for males which we require. So in this course, I'll be teaching you all possible ways to retrieve the data. At the end of the day, it will be up to you, your preference, which way or which formula you would like to use it. But as a researcher, you should know all the possible ways. The other thing is, whenever I specify any observation within the character variable, for example, these are observation within each variable. Each is a numeric variable. These are observation within sex variable, which is a character. These are observations within name variable. Whenever I specify observations within character variables such as name, sex, or ag level, I would have to specify them in single quotes because characters are case sensitive. When we were young, we learned about small a, small b, capital B. So that is why only characters are case sensitive. And if we have to specify these observations within character variables, we have to specify it in quotes. For numerics, we don't have to. So let's do data mining here. Let's retrieve only data for males which we require. So I'll close this data here. I'll come to the program editor. So in a data command, anything before the equal to sign is the name of the variable. Anything after the equal to sign is the observation within the specified variable. For example, sex is equal to capital M. Sex is the name of the variable. Capital M is an observation within the sex variable. Alright, I'll read this command here. Data work.male semicolon set work.admit semicolon where sex is equal to capital M semicolon run semicolon. In this command here, I'm using a where condition. I'm saying wherever in the sex variable is equal to capital M. Now if you see, I've mentioned capital M in quotes because it's case sensitive. It's an observation within the sex variable and capital M is a character, so I have to specify it in quotes. If there was small m in the data, then here also I would have to write exactly small m and specify it in quotes. But since there was capital M, so I have to write capital M and specify in quotes. So it's a where condition here. So it will only read where sex is equal to capital M. Whatever the answer is, it will create in the work library by the name male. You can give any name to your data. I'm just giving the name male because I'm retrieving data for males here. So this time we're going to read it from work.admit. We're not going to read from SAS user.admit anymore because we have created the data in the work library. So we'll read it from work.admit. Run semicolon. So I'll select this. I'll run. I'll show you the log window. So here the log says there were 10 observations read from the dataset work.admit where sex is equal to capital M. The dataset work.male has 10 observations and 9 variables. So because it's a where condition, it has only read 10 observations from the dataset work.admit where sex is equal to capital M. It has created the data in the work library by the name male. This data has 10 observations and 9 variables. So I'll open this male data here. So in this data, we have only data for males here, 10 observations and 9 variables. So what we've done here is we have done data mining. We have only retrieved data for males which we require. So this is known as data mining. You only mine data which you require for your research report. So this is one way using a where condition. Now I'll show you another way, this time using an if condition. I'll close this data here. I'll come to the program editor. So I'll read this command here. Data work.male1 semicolon set work.admit semicolon if sex is equal to capital M semicolon run semicolon. So if you see this time here, I'm using an if condition. Earlier I used a where condition. This time I'm using an if condition. This time I'm saying if sex is equal to capital M. So if you see capital M also I've specified in quotes this time because it's a character within the sex variable. So which means it will read if sex is equal to capital M. Whatever the answer is, it will create in the work library by the name male1. Again, you can give any name to your data set. This time I'm just giving the name male1 just because I want to differentiate from this male data that we already have. This time again I'm reading it from work.admit if sex is equal to capital M. Run semicolon. I'll select this and run. I'll check the log. The log says there were 21 observations read from the dataset work.admit. The dataset work.male1 has 10 observations and 9 variables. Now because it's an if condition, so it has read 21 observations from the dataset work.admit. It has created the data in the work library by the name male1 this time. This data has 10 observations and 9 variables. So I'll open this mail1 data here. So if you see here, we have again only retrieved data for mails which we require. This is another data mining technique using an if condition. Alright, so now you might be wondering that what is the difference? Earlier also we did a where condition, we retrieved the same data. This time we use an if condition, we got the same answer. I'll close this. Now if you see, by reading the note, you will see the difference between using if and where condition. When we use a where condition, it will only read the values that you specified. Here we mentioned in the command where sex is equal to capital M, so it has read only 10 observations from work.admit where sex is equal to capital M, because there are only 10 observations in admit data where sex is equal to capital M. Whereas when we use an if condition reads the entire data, the entire 21 observations, and still gives you the desired results that you require. Which means where is a faster command because it only reads the value that you specify. So when you're working in an organization, especially when you're working with big data, you would prefer to use a where condition instead of an if condition, because where will read faster and will give you faster results. So this is one of the difference between if and where condition. Alright, now I'll show you another way of retrieving the same data. I'll come to the program editor. I'll read this command here. Data work.mail2 semicolon set work.admit semicolon. If sex is equal to capital M, then output semicolon run semicolon. So in this command here, I'm using an if condition, then action. I'm saying if sex is equal to capital M, this is the condition. The action is it will create an output in this work library, this time by the name mail2. Again, it's reading from work.admit. If condition, then action. I'll select this and run. Now I'll check the log. The log says there were 21 observations read from the dataset work.admit. The dataset work.mail2 has 10 observations and 9 variables. Because it's an if condition again, so it has read 21 observation. It has read the entire data from work.admit. This work.mail2 again has 10 observations and 9 variables. So I'll open mail2. So again here we have only retrieved data for mails which we require. This time using if condition then action. But the thing is, with a where condition, you cannot write a then statement like we did here with an if condition. We can only do that with an if condition. We cannot write a then statement with a where condition because where is a surety. When you say where sex is equal to capital M, it means you're sure you only want to read where sex is equal to capital M. Statement ends there. But when you say if is a probability. So you can write a then statement with an if condition only, not with a where condition. So this is another difference between where and if condition. Alright, now I'll show you another way to retrieve the same data. So I'll read this command here. Data work.mail semicolon set work.admit semicolon. If sex is equal to capital F, then delete semicolon run semicolon. So if you see in this command again, I'm using if condition then action. This time I'm saying if sex is equal to capital F, this is the condition. The action is delete. Because we're retrieving the data for mails here, so if we delete all the capital F, the rest will be remaining capital M. So if you see capital F also, I have specified it in quotes because it's a character within the sex variable. If condition then action again. Now if you notice here, I've given the same name work.mail. I've already created a data by the name work.mail. Now I'm giving the same name again. So the thing is, in your computer, if you try to copy a file to a folder, and if that file already exists, your computer will give you a warning saying, are you sure you want to copy this file? But in SAS, if you give the same name, it will not give you a warning. It will neither give you an error. What this will do is, it will automatically overwrite this previous data that we already have. So we already created the data by the name mail in the work library. Now when we run this command, it will overwrite this mail data that we already have. So I'll select this and run. I'll show you the log. The log says again, there were 21 observations read from the dataset work.admit. The dataset work.mail has 10 observations and 9 variables. So the thing is, earlier also in work.mail we have 10 observations and 9 variables because we're retrieving data for mails. This time also we have deleted all the capital F. We have again in work.mail 10 observations and 9 variables. We have override this mail data that we already have, but it won't make such of a difference because earlier also we have retrieved the same data for mails. This time also we have retrieved the same data for mails. So overwriting won't make such of a difference now. Later on when we run a different command, I'll show you the difference of overwriting. So what we've been doing here is data mining for males. So similarly, you can do it for females as well. Now when I talk about data mining, it does not necessarily mean that we can only mine or segregate data in terms of male and female. We can also do it in age category, date, height, weight category. So now let's say your team now has to work on age category above 50 and my team has to work on age category below 50. So we can do data mining here. We can only retrieve data for ages above 50 and ages below 50. Now, if you're working on ages above 50 and if I'm working on age below 50, we might have one problem here where a lot of people in the age category of 50 will not be included. So now your manager asks you to include 50 in your team. So we can do that as well using data mining technique. We can include 50 and above 50 also in your team. I'll show you how to do that. Now let's just imagine we have a very big data here, and you want to segregate data in different age categories such as ages from 1 to 10, 11 to 20, 21 to 30. We can also do that using data mining technique. Now let's just take a scenario that there is a specific kind of virus which only targets specific age categories only. Let's say this virus targets only age category 27, 34 and 31. So rather than working on the entire data here, what you can do is you can do data mining. You can only retrieve age categories that you want to do research on. Alright, so let's close this and let's see how do we retrieve data now in different age categories. I'll come to the program editor. I'll read this command here. Data work.age semicolon set work.admit semicolon where age is greater than 50 semicolon run semicolon. So this time I'm using a where condition again. I'm saying wherever in this age variable is greater than 50. So which means it will only read where age is greater than 50. Here if you see 50 as an observation within this age variable, and 50 I did not specify it in quotes because it's numeric. I only have to do that with characters. So it will only read where age is greater than 50. Whatever the answer is, it will create in the work library, this time by the name age. Again, it's reading from work.admit semicolon run semicolon. I'll select this and run. Now I'll show you the log. The log says there were 3 observations read from the dataset work.admit where age is greater than 50. The dataset work.age has 3 observations and 9 variables. So because it's a where condition, so it has only read 3 observations from work.admit where age is greater than 50. It has created the data in the work library by the name age. This data has 3 observations and 9 variables. So I'll open this age data here. Here we only have ages above 50. All these people are in the age category above 50. Alright, so we said earlier that we might have one problem where if you're working ages above 50 and if I'm working below 50, a lot of people in the age category of 50 will not be included here. So now your manager asks you to include 50 in your team as well. So let's see how do we do that. I'll close this. I'll come to the program editor. So this is the command for that. I'll read this. Data work.h1 semicolon set work.admit semicolon where age is greater than equal to 50 semicolon run semicolon. Now if you see here, I've mentioned where age is greater than equal to 50. Earlier I just mentioned greater than, so only ages above 50 came. This time because of equal to, so even 50 would be included. So it will only read where age is greater than equal to 50 because it's a where condition. Whatever the answer is, it will create in the work library by the name H1 this time. Again, we're reading from work.admin. I'll select this and run. Now I'll show you the log. The log says there were 3 observations read from the dataset work.admin where age is greater than equal to 50. The dataset work.h1 has 3 observations and 9 variables. So h1 has 3 observations and 9 variables. So I'll open h1 data here. So again here we have only retrieved data ages above 50. Why? Because in admit data there is no one in the age category of 50 here. If there was here in admit data, because we've mentioned greater than equal to 50, then even 50 would have been included here. But since there was no one in the age category of 50, that's why we only have ages above 50 here. Alright, so I was telling you that there are multiple ways to do a similar thing. So another way to retrieve the same answer is this command here using mnemonic symbols. So I'll read this command here. Data work.h2 semicolon set work.admit semicolon where age gt 50 semicolon run semicolon. So if you see this time I'm using this mnemonic symbol gt. So the reason we use these mnemonic symbols such as gt, lt for greater than, less than is because we here in India we have learned mathematics from a very young age. So we're very familiar with all these greater than, equal to sign, less than sign. But in other countries such as America, Great Britain, students there they learn mathematics only after grade 6 or grade 7. So a lot of people are not very familiar with these signs and symbols like we do here in India. So that is the reason we use these mnemonic symbols such as GT, LT and all that, so that anyone working in an organization will not get confused seeing these signs and symbols here. They will understand that to retrieve the same answer, you can do it in multiple different ways. So that's the reason we use these mnemonic symbols such as GT, GE, LT, and many more, which you can learn from the Little SAS book. Today, I'm just showing you how to use these mnemonic symbols here. So again, it's a where condition, so it will only read where age is greater than 50. Whatever the answer is, this time it will create it in the work library by the name h2. Again, it's reading from work.admin. I'll select this and run. I'll show you the log. Here, the log says again, there were 3 observations read from the dataset work.admin where age is greater than 50. The dataset work.h2 has 3 observations and 9 variables. In the command, we have mentioned where age gt50. In the log, it has said where age greater than, it has shown us as this symbolic sign. So you can either write it this way or write it this way, you'll get the same answer. So we've done this earlier also. We got 3 observations and 9 variables, age greater than 50. This time also, age greater than 50. In h2, we have 3 observations and 9 variables. So I'll open h2 data here. Again, we have only retrieved data ages above 50 here. Alright, now let's do this other one here. I'll close this. Now I'll come to the program editor. Now I'll read this command here. Data work.age semicolon set work.admit semicolon where age lt 50 semicolon run semicolon. This time I'm using this mnemonic symbol lt. This is less than. So this time it will only read where age is less than 50. Whatever the answer is, if you see again here, I've mentioned the same name work.age. We already created the data by the name work.age. This time I'm giving the same name work.age again. So I mentioned that if you give the same name, it will not give you a warning, will neither give you an error. It will automatically overwrite the previous data that we already have. So in age data earlier, we have ages greater than 50. Now we'll do age less than 50. We will overwrite this age data that we already have. So we'll not have ages greater than 50 anymore this time. We will have only ages less than 50. I'll select this and run. I'll show you the log. The log says there were 18 observations read from the dataset work.admit where age is less than 50. The dataset work.age has 18 observations and 9 variables. In the command, we have mentioned this lt. Here in the note, it has given us as this symbolic sign. So you can either write it this way or write it this way, you'll get the same answer. Because we've given the same name work.age, it has override this previous data that we already have. Age data earlier has 3 observations and 9 variables. This time we have override that data. We have 18 observations and 9 variables in age data. I'll open this. Here we have only ages less than 50. We don't have any age above 50 here. So I was telling you earlier that you can also segregate data in different age categories such as from 1 to 10, 11 to 20, 21 to 30. So let's see how do we do that now. I'll close this. I'll come to the program editor. This is the command for that. I'll read this. Data age semicolon set work.admit semicolon where age between 35 and 45 semicolon run semicolon. So this time I'm using a where condition again. I'm saying wherever in this age variable is between 35 and 45. Now because we've mentioned and here, so even 35 and 45 would be included here. And if you notice here, I've just given the name of the data. I did not specify the name of the library where to create this data. All this while I used to write work.age, work.age2, work.age1. This time I just mentioned the name of the data age. So here if you don't mention where to create this data, SAS will automatically create it in the work library, which is a temporary library. If you want to create it in other libraries, if you don't mention, then it will not work. You have to mention the name of the other libraries that you want to create in. But if you don't mention which library to create in, SAS will automatically create it in the work library, which is a temporary library. So in work library, we already have a data by the name age. Now we've given the same name age again. So which means it will override this age data in the work library since it's automatically going to be created in the work library. So it will override this age data that we already have. Earlier we have ages less than 50. This time when we run this, we'll have only ages between 35 and 45 in age data. I'll select this and run. I'll show you the log. The log says there were 6 observations read from the dataset work.admit where age greater than equal to 35 and age less than equal to 45. The dataset work.age has 6 observations and 9 variables. So if you see here in the command, I've mentioned where age between 35 and 45. Here in the note, it has given us using these symbolic signs. So you can either write it this way or write it this way, you'll get the same answer. We did not mention where to create this data. It has automatically created in the work library by the name age. And because we already have a data by the name age in the work library, so it has override this age data that we already have. Earlier we have 18 observations and 9 variables. Now in age data we have 6 observations and 9 variables. I'll open age data. We have only ages between 35 and 45 here. Alright, I'll close this data now. So to retrieve the same data, you can either do it this way or do it this way, or another way is we can do it this way as well. So I'll read this command here. Data age semicolon set work.admit semicolon where 35 less than equal to age less than equal to 45 semicolon run semicolon. So in this command here, I'm looking for the same answer like I did previously. But since I told you I'll be teaching you multiple different ways, so this is another way. So if you feel comfortable using this command, you can do this. If you feel like you want to use this, you can do this. Both will give you the same answer. So again here, I did not mention the name of the library. So it will automatically create it in the work library. And since we already have a data by the name age, it will overwrite this previous data. But this time overwriting won't make such of a difference because we're retrieving the same data, ages between 35 and 45. I'll select this and run. I'll show you the log. So again, earlier also we did age between 35 and 45. We got this note. Here also we did this command. We got this note here. So you can either write it this way or write it this way. You'll get the same answer. So again, earlier also we have 6 observations and 9 variables. This time we have again 6 observations and 9 variables because we're retrieving data ages between 35 and 45. Alright, I'll close this. So earlier we said that rather than working on the entire data, if you want to target only specific age categories, you can do that using data mining technique. Let's say you only want to target age category 27, 34 and 31. So we can do that. Let's see how do we do that. I'll close this, come to the program editor. This is the command for that. Data age semicolon set work.admit semicolon where age in open bracket 27 comma 34 comma 31 close bracket semicolon run semicolon. So if you see here, I've mentioned where age in 27 comma 34 comma 31 because it's a where condition, so it will only read where age in 27, 34 and 31. And the reason I've separated them with comma is because these are observations within the age variable. So it will only read where age is in 27, 34 and 31. Whatever the answer is, this time again, I did not mention the name of the library, so it will automatically create it in the work library and it will override this age data that we already have. Earlier we have ages between 35 and 45. This time we'll override that. We'll have age in 27, 34 and 31. I'll select this and run. I'll show you the log. The log says there were 4 observations read from the dataset work.admit where age in 27, 34 and 31. The dataset work.age has 4 observations and 9 variables. So I'll open age data. We have only ages 27, 34 and 31. 34 came twice here because in admit data there are 2 people in the age group of 34. Alright, I'll close this data now. Now let's say in this admit data here, you want to work on the other age categories now. Let's say you want to understand the immune system and study them to know why these other age categories are not affected by this specific kind of disease. So one way you can do that is how we did earlier. Age in 43, 51, 29, and mention all of these, which would be a long list. That is one way. The other way is, let's say you don't want 27, 31, 34. What we can do here is we can just exclude the ones that we don't need. So if you don't want 27, 34 and 31, we can just exclude that using data mining technique. So let's see how do we do that. I'll close this. I'll come to the program editor. This is the command for that. I'll read this. Data age semicolon set work.admit semicolon where age not in 27, 34, 31 semicolon run semicolon. So this time I've mentioned where age not in. Earlier I did where age in, so only 27, 34 and 31 came. This time I've mentioned where age not in. So 27, 34 and 31 will not come this time and the rest of the data will come. So again, I've given the same name age, so it will override this age data that we already have. I'll select this and run. I'll show you the log. The log says there were 17 observations read from the dataset work.admit where age not in 27, 31, 34. The dataset work.age has 17 observations and 9 variables. So I'll open age data. So here we have all the other age categories except for 27, 34 and 31. Alright, now if you see in this data, we have all these variables here: ID, name, sex, age, date, height, weight, act level and fee. We have 9 variables and 21 observations. Now let's say as a researcher, you don't want to work with all the variables for now. Let's say you only want to work on specific variables only which you require for today's data mining process. Let's say you only want to work on name variable, age variable and height variable. So there is a command which is known as a keep command. Keep command means keeping the desired variables. And there is another command which is known as a drop command. It will drop the undesired variables, dropping the variables which you don't desire for today's results. So let's see how do we use a keep and drop command over here. I'll close this data. I'll come to the program editor. So this is the command for that. I'll read this. Data req underscore var semicolon set admit open bracket keep equal to name age height close bracket semicolon run semicolon. In this command, I'm using a keep command. I'm saying that I want to keep only name variable, age variable, and height variable. Earlier, I separated them with comma because these are observations within the variable. This time, I'm mentioning the name of the variable, so I separate them with spaces. So I only want to keep name, age, and height variable. This time, I did not mention again the name of the library, so it will automatically create it in the work library. This name is just short for required variables because we're doing keep and drop command. You can give any name of the data set. And if you see here, all this while I used to mention set work.admit, set work.admit, set work.admit. This time I just mentioned the name of the data, admit. I did not mention the name of the library where to read it. So again here, if you don't mention the name of the library where to read it, SAS will automatically read it from the work library, which is a temporary library. If you don't mention, it will automatically read it from here. So now to read it from the work library, the data has to be present here. Let's say if this admit data was not present here and we did not mention the name of the library where to read it, it will not give us the answer because it will automatically read it from the work. And if that data is not there in the work, it will not have any data to read from. So to read a data, it will have to be present in the work library. To create the data, it will automatically be created anyhow. But to read, the data has to be present in the work library. So I'll run this command here. So in admit data, we usually have 9 variables. Now I'll only keep name, age, and height variables. So we'll only have 3 variables this time. I'll select and run. Open the log. So here there were 21 observations read from the dataset work.admit. The dataset work.req underscore var has 21 observations and 3 variables. Because we use a keep command, we mention only these 3 variables. That's why we have only 3 variables now. In the command, we did not mention where to create it and where to read it from. Automatically, it has read it from the work library by the name admit and create it in the work library by the name req underscore var. I'll open req underscore var. Here we have only name, age, and height variable. Now let's just say now in this admit data here, you want to work with all the variables, but except for a few variables only. Let's say in this data, you don't want to work on date variable. So one way you can do that is mentioning a keep command. You'll mention keep ID, name, sex, age, and all these other variables, which would take you a long time. The other way is we can just use a drop command and drop the undesired variables. So if you don't want date variable here, we can just drop that. So let's see how do we use a drop command here. I'll close this. I'll go to the program editor. This is the command for that. I'll read this. Data req underscore var semicolon set admit open bracket drop equals date close bracket semicolon run semicolon. So this time I'm using a drop command here. I'm saying I want to drop this date variable. Let's say instead of just date variable, we'll drop 2 variables, date and sex variable. So in admit data, we usually have 9 variables. Now if I drop date and sex variable, so we'll have only 7 variables this time. So I've given the same name, so it will override this. So now we'll not have only 3 variables. We'll drop 2 variables. We'll have 7 variables this time. I'll select and run, show you the log. Here req underscore var has 21 observations and 9 variables because we're dropping date and sex variable. We have override this data here. I'll open req underscore var. Now we have all the other variables here except for date and sex variable. Alright, now I'll close this data. I'll open admit data. So at times when you're working in an organization, what these organizations will do is they will want to keep a lot of things private because they don't want to share everything with everyone who's working in their organization. so that these people won't go tell the world what this organization is working on or researching on. So what these organizations do to keep their data secure is they use a command which is known as a rename command. What they do is they rename the variables. Like for example, let's say in this data here, a lot of people might not feel comfortable sharing maybe about their age or height or weight. So what we'll do here is we'll rename these variables here. Let's rename height and weight variable. I'll close this data. Let's see how do we use a rename command here. This is the command for that. I'll read this. Data req underscore var semicolon set admit open bracket rename equal to open bracket height is equal to x weight is equal to y close bracket semicolon run semicolon. So in this command here, I'm using a rename command this time. I'm gonna rename this height variable into x and this weight variable into y. You can give any name of the variables. I'm just giving x and y. So again, we're gonna overwrite req underscore var. So this time we'll not keep or drop commands. So we'll have again 9 variables because we are just renaming the variables. So we have 21 observations and 9 variables. So I'll open req underscore var. We have just renamed height into x and weight into y. So if you are a new person looking at this data, then you would never know what is x and what is y. So this is how organizations they keep their data secure, by renaming the variables. Alright, now if you see here, we have this name variable. Now in this name variable, we have a lot of people with different names out here. Now let's say this time I only want to work with individuals that have small a in their name. If you see, this first name has small a in the name. The second one doesn't have small a in the name, so I don't want that. Third one has small a in the name. So I only want to work with individuals that have small a in the name. So let's see how do we do data mining here and only retrieve data which only had small a in the name. So let's see, I'll close this, come to the program editor. So this is a command for that. I'll read this. Data name semicolon set admit semicolon where name question mark small a semicolon run semicolon. This time I'm using a where condition again. I'm saying wherever in this name variable question mark means contain. So I'm saying wherever in this name variable contains small a. And because I'm looking specifically for small a, so I have to write exactly small a and specify in quotes because it is case sensitive. So it will only read where name contains small a. Whatever the answer is, it will create in the work library by the name. I'll select this and run. I'll show you the log. Here it says there were 8 observations read from the dataset work.admit where name contains small a. The dataset work.name has 8 observations and 9 variables. So here in the command we have mentioned where name question mark small a. In the note it has given us like this. So you can either write it this way or write it this way. You'll get the same answer. Name data has 8 observations and 9 variables. So I'll open name data here. We have 8 observations because 8 people have small a in their name here. All these people contain small a in their name. Alright, so I was telling you that there are multiple ways to do a similar thing. So another way to retrieve the same data is we can use this command here. This is the command for that. I'll read this. Data name1 semicolon set admit semicolon where name like percentage small a percentage semicolon run semicolon. This is like percentage small a percentage. In this command, I'm looking for the same answer like I did previously. This is just a different command now. Percentage small a percentage means it will read anywhere where there is small a in the name. Whatever the answer is this time, it will create in name1 data. I'll select this and run. I'll show you the log. Since we're retrieving the same data, so again this time in name1 we have 8 observations and 9 variables. So I'll open name1. Again we have only people that have small a in the name here. 8 observations and 9 variables. Alright, I'll close this. Now let's do this other command here. I'll read this. Data name2 semicolon set admit semicolon where name like capital A percentage semicolon run semicolon. This time I did not mention percentage on both sides. I only mention percentage after capital A. So which means here I'm only looking for names who's starting with capital A in the name variable. So it will only read where name is starting with capital A. Whatever the answer is, it will create in this name to data. I'll select this and run. I'll show you the log. So here name to data, we have only one observation because in admin data there is only one person whose name is starting with capital A. That's why only one observation came here. Alright, I'll close this. Now let's do this other one here. Data name tree semicolon set admit semicolon where name like percentage capital A semicolon run semicolon. This time I've mentioned percentage before capital A. So which means I am looking for people whose name is ending with capital A this time. Whatever the answer is, it will create in name tree data. I'll select and run. I'll show you the log. So again here in name tree data, we have only one observation because there is only one person in admin data whose name is ending in capital A. Alright, I'll close this one. Now we'll do this other command here. Data male female semicolon set admit semicolon. If sex is equal to capital M, then output male semicolon. If sex is equal to capital F, then output female semicolon run semicolon. Now if you remember the rules of naming data sets is that you cannot give spaces in between. Now I've given a space in between male and female. So now SAS will then encounter this as two separate data this time. It will create a male and a female data from a single data command. I did not mention where to create these data. Automatically it will be created in the work library. It's gonna read it from work.admin. I'm using if condition then action here. I'm saying if sex is equal to capital M, this is a condition, then it will create an output in this male data, which is this one. If sex is equal to capital F, then it will create an output in this female data, which is this one. So earlier also we've done something like this, but here I did not mention where to create this data because in this command I'm only creating one data only. So automatically it will be created in this one data only. But this time I've mentioned two separate data, so I have to mention which condition to go where. So this M will go into male data and capital F will go into female data. I'll select this and run. I'll show you the log. So the log says there were 21 observations read from the dataset work.admit. The dataset work.male has 10 observations and 9 variables. The dataset work.female has 11 observations and 9 variables. So it has created male and female data. Both has been created in the work library because we did not mention the name of the library. Male data has 10 observations, female data has 11 observations. Because it's an if condition, so it has read the entire 21 observation. 10 plus 11 is 21. So we have this male data and we have female data. I'll open male and female data here. All the data for females here. And this is all the data for males here. Alright, I'll close this. Now I'll open admit data here. So all this while we have been using this admit data to learn about different data mining techniques. We segregated the data for males and females. We worked on different age categories. We also did data mining in this name variable. So this time we'll learn further data mining techniques. We'll learn how to create new variables this time. All this while we have been working with 1, 2, 3, 4, 5, 6, 7, 8, 9 variables. This time we'll learn further data mining technique. We'll learn how to create separate variables. Alright, now let's just take a scenario that this fee here is the insurance amount which everybody has to pay. Let's say this male here at the age of 27, he wants to take the insurance policy 2 years from now, maybe at the age of 29. And this female here at the age of 34, she wants to take the insurance policy 5 years down the line, maybe at the age of 39. So now, during that 2 years time and 5 years time, a lot of changes would have happened to the physical appearance of these individuals. Their height can change, their weight can change, their blood sugar can change, their heart rate, their pulse rate. So a lot of things would have happened to these individuals. So now you want to understand and calculate whether these people are still eligible or not to take the insurance policy 2 years from now and 5 years down the line. So what we can do here is we can use data mining. We can create a new variable, let's say maybe by the name age2, where we're going to plus 2 for all the males here and plus 5 for all the females. So that by having a separate variable of future age of 2 years from now for males and 5 years from now for females, we can do a competitive and comparative analysis between present age and future age to see if these people are still eligible or not to take the insurance policy 2 years from now and 5 years from now. That is one way we can do that. Another way is, let's say you don't want to create separate variables. You want to make the changes in the existing age variable, where you want to plus 2 for all the males here and plus 5 for all the females here in the existing age variable. So that is another way, using data mining technique, we can make changes to these observations here. Or let's say you want to create separate variables for males separately and for females separately, where you want to plus 2 for all the males and plus 5 for all the females. So we can do all of that using data mining techniques here. So let's see how do we do all of that. I'll close this data here. I'll come to the program editor. So always remember, in a data command, anything before the equal to sign is the name of the variable. Anything after the equal to sign is the observation within the specified variable. Alright, now I'll read this command here. Data admit to semicolon set admit semicolon. If sex is equal to capital M, then age2 is equal to age plus 2 semicolon. If sex is equal to capital F, then age2 is equal to age plus 5 semicolon. Run semicolon. So this time I've created a new data by the name admit2. I'm picking it up from admit data. So both will be created and picked it up from the work library because I did not mention the name of the library. I'm using if condition then action again here. I'm saying if sex is equal to capital M, this is the condition. Then the action is it will create this age2 variable because anything before the equal to sign is the name of the variable. So it will create this age2 variable where it's gonna plus the present age plus 2 for all the males. If sex is equal to capital F, then in this age2 variable, it's gonna plus the present age plus 5 for all females in this age2 variable. So in admit data, we usually have 9 variables. Now I'm gonna add age2 variable. So we'll have a total of 10 variables created in admit2 data. I'll select this and run. I'll show you the log. Here the log says there were 21 observations read from the dataset work.admit. The dataset work.admit2 has 21 observations and 10 variables because we added age2 variable. So I'll open admit2 data here. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 variables. We added this age2 variable where we have plus 2 for all the males. If you see this 27, now plus 2 has become 29. This 51 plus 2 has become 53. Plus 2 for all the males and plus 5 for all females here. 34 plus 5 is 39. 31 plus 5 is 36. So this way, by having this separate variable like this of future age, we can do a competitive and comparative analysis between present age and future age to see if these people are still eligible or not to take the insurance policy 2 years from now and 5 years down the line. Alright, we also said earlier that rather than creating a separate variable like this, you can also make these changes in the existing age variable where you want to plus 2 for all males and plus 5 for all females. So let's see, this time we'll not create separate variable. We'll make changes in the existing age variable. I'll close this data here. I'll come to the program editor. I'll read this command here. Data admit to semicolon set admit semicolon. If sex is equal to capital M, then age is equal to age plus 2 semicolon. If sex is equal to capital F, then age is equal to age plus 5 semicolon. Run semicolon. Now if you see here, this command is almost the same as the previous command. The only difference is that I don't want to create a separate variable. I want to make changes in the existing age variable. So I mentioned the name age variable. Earlier I created age2 variable, so we got a separate variable age2. This time I mentioned age variable. We already have a variable by the name age in admit data. Now when we mention the same variable, it will override that age variable that we already have in admit data. This time I'm gonna run the same admit2 data again, so it will overwrite this data that we already have. So this time we'll not have separate variable, we'll have again 9 variables because we're making changes in the existing age variable. So if sex is equal to capital M, then in this existing age variable, it will plus present age plus 2 for all the males. If sex is equal to capital F, in the existing age variable, it's gonna plus present age plus 5 for all females. Run semicolon. So this time when I run this, we'll overwrite admit2 data. This time we'll not have 10 variables because we're making changes in the existing age variable. So this time we'll have 9 variables in admit2 data. If you see, admit2 data here has 21 observations and 9 variables because we made changes in the existing age variable, where we plus 2 for all the males, that 27 earlier now has become 29, and plus 5 for all females. Alright, so we also said earlier that we can create separate variable for males separately and females separately. So let's see how do we do all of that now. This is the command for that. I'll read this. Data admit2 semicolon set admit semicolon if sex is equal to capital M, then age2 is equal to age plus 2 semicolon. If sex is equal to capital F, then age3 is equal to age plus 5 semicolon. Run semicolon. Now if you see again, this command is again exactly the same as the previous two command. The only difference is that I wanted to create separate variable for male and female. So I mentioned age2 and age3 variable here. So if sex is equal to capital M, then in this age2 variable, it's gonna plus present age plus 2 for all the males. If sex is equal to capital F, then in this age3 variable, it's gonna plus present age plus 5 for all the females. This time I've mentioned the same name of the data again. So when we run this, we'll overwrite this data. This time we'll not have just 9 variables. Now we're adding age2 and age3 variables. So now we'll have a total of 11 variables created in admit2 data. We have admit2 21 observations and 11 variables because we added age2 and age3 variable. I'll open admit2. We have age2 for males where we have plus 2 for all the males, and age3 for females where we have plus 5 for all females. And here, because these two are numeric variables, age2 and age3, that's why the missing has been highlighted with a dot. If these were character variables, then the missing would just be blank. So now let's take a hypothetical situation. Let's say that whenever we encounter males, they are from Delhi, and whenever we encounter females, they are from Bangalore. So now we have been told by our manager to create a separate variable by the name city and include Delhi for all the males and Bangalore for all females. So let's see how do we do that. I'll close this. I'll come to the program editor. I'll read this command here. Data admit2 semicolon set admit semicolon if sex is equal to capital M, then city is equal to Delhi semicolon. If sex is equal to capital F, then city is equal to Bangalore semicolon. Run semicolon. Now if you see, this command here is again almost the same like the previous 2-3 commands. The only difference this time is that I'm creating a new variable by the name city where I'll include Delhi for all the males. If sex is equal to capital F, then in the city variable it will be Bangalore for all females. And because Delhi and Bangalore, they are characters, so I have to specify it in quotes because characters are case sensitive. These are numeric variables, so I don't have to specify in quotes, only for characters. So if condition, then action again. So if I run this command now, it's gonna overwrite this admit2 data. So now we'll not have 11 variables, we're just adding city variable. So we'll have a total of 10 variables created now in admit2 data. I'll run this, show the log. Admit2 has 21 observations and 10 variables because we added city variable. I'll open admit2. Here we have added city variable where we have include Delhi for all the males and Bangalore for all females here. Now if you see carefully here in the city variable, the name Bangalore was not written completely. If you see, only 5 letters of Bangalore came, B-A-N-G-A, which is 5. Now if we count the length for Delhi also is 5. That is because in the command here, we had mentioned Delhi first and Bangalore at the bottom. So it has automatically taken the length for Delhi, which is 5. That's why only 5 letters of Bangalore came. Let's say in this command here, we had mentioned Bangalore first and Delhi at the bottom. So automatically, Bangalore also will come completely and Delhi also will come completely. But that is not the right way to do it, because as of now, we have just a small data here. With just one glance, we can see if some names have come out right or not. But if we're working in an organization, if we're working with big data that has thousands of observations, that time it might not be a possibility to check in every observation to see if all the names have come out right or not. So the right way to do is we have to specify the length for this city variable. As of now, when I double click on city variable, since city is a character variable, so it has a $sign, the length here is 5. That is because it has taken the length for this Delhi here. So $5 dot is the backend coding for this city variable. So we have to specify the length for this city variable using the length statement. So let's see how do we do that. I'll close this. This is a command for that. I'll read this. Data admit to semicolon set admit semicolon length city $10 dot semicolon. If sex is equal to capital M, then city is equal to Delhi semicolon. If sex is equal to capital F, then city is equal to Bangalore semicolon. Run semicolon. Now if you see this command here, is again exactly the same as the previous command. The only thing that we change here is because we wanted to change the length for this city variable, so we specified the length command. We're specifying the length for this city variable. Now city is a character variable, so we have to give a $sign because the backend coding starts with a $sign. Now I've specified the length to be 10 here because Bangalore has 9 letters, so if I give 10, automatically Bangalore also will come and Delhi also will come. $10 dot because the backend coding starts with a dollar and ends with a dot. You can give any length here. Let's say instead of 10 you want to give 20, so we'll specify the length for this city to be $20 dot. So we'll overwrite admit2. We'll have again 10 variables created. I'll open the log. Admit2 has 21 observations and 10 variables. I'll open admit2 here. If you see here, we specified the length for this city variable. Now Bangalore also has come completely and Delhi also has come completely. Now when I double click on city variable, also the backend coding has changed to $20 dot. Alright, now so some people used to ask, like, is it necessary that we always have to use the length statement at the top? Can we use the length statement at the bottom like this? So this is everything like the previous command. The only thing is that we've specified the length statement at the bottom. So let's see if this will work. I'll select this and run. I'll show admit2 data. It did not work. It did not work because I'll show you the log here. The warning here says the length of character variable has already been set. Use the length statement as the very first statement in the data step to declare the length of a character variable. So we always have to use the length statement first, because if we use it at the bottom, it will again take the length for this Delhi. So this will not work. Only specifying the length statement first will work. Alright, so all this while we have been learning about if condition, where condition, if condition, then action. This time we'll learn about else condition. Else meaning apart from this. So I'll read this command here. Data admit2 semicolon set admit semicolon. If sex is equal to capital M, then age is equal to age plus 2 semicolon. Else age is equal to age plus 5 semicolon. Run semicolon. Now in this command here, I'm looking for the same answer like I did previously with this command, where I want to plus 2 for all the males in the existing age variable and plus 5 for all females in the existing age variable. This time the command is different. Instead of writing the condition again, I just mention an else condition. I just said if sex is equal to capital M, then age is equal to age plus 2. Else, because apart from capital M, the rest is all capital F in admit data. Else age is equal to age plus 5, so it will do age plus 5 for the rest of the condition. This time I just mentioned an else command. I did not have to mention if sex is equal to capital F again. I just mentioned else. So this time when I run this, we'll again have 9 variables because we're making changes in the existing age variable. I'll select this and run, show you the log. So again we have 9 variables in admit2 data. I'll open admit2. So we have done this earlier. we have +2 and +5 for males and females in existing age variable. Alright, I'll close this now. I'll come to the program editor. Now we'll learn about do command. Now we use a do command when we want to do multiple actions together for the same condition. Now this do command generates a loop in the system, which means it gets created continuously. So with this do command, you always have to specify an end command to stop the loop. So I'll read this command here. Data admit to semicolon set admit semicolon if sex is equal to capital M, then do semicolon age is equal to age plus 2 semicolon height is equal to height plus 2 semicolon weight is equal to weight plus 2 semicolon n semicolon. If sex is equal to capital F, then do semicolon age is equal to age plus 5 semicolon height is equal to height plus 5 semicolon weight is equal to weight plus 5 semicolon n semicolon run semicolon. Now what I'm doing in this command is I want to +2 for all the males in existing age variable, height variable, existing weight variable. But this time I wrote the command differently. Normally I would have written like this. If sex is equal to capital M, then age is equal to age plus 2. Then I would have written again if sex is equal to capital M, then height is equal to height plus 2. Then I would have written again if sex is equal to capital M, then weight is equal to weight plus 2. I did not do that this time because I want to do all these actions for the same condition. So I just mentioned the condition once, and I mentioned a do command because we use a do command when we want to do multiple actions for the same condition. So I just said if sex is equal to capital M, then do all these actions for this sex is equal to capital M. Now this do command generates a loop, so we have to specify an end command. So I give an end command semicolon. Now I give another condition. If sex is equal to capital F, then do all these actions for sex is equal to capital F. So this time again, when I run this, we'll not have new variables because we're making changes in existing age, height and weight variable for both male and females. I'll select this and run. I'll show you the log. So in the log again, we have 9 variables. I'll open admit to. So we have made changes in existing age, height and weight variable. We have +2 and +5 for males and females respectively in age, height and weight variable. I'll just open with admit data here just to show you the difference. If you see earlier in age data, this male here is 27, +2 up there is 29. This 34 +5 is 39 for females. In height also 72 up there is 74, 66 up there is 71. In weight 168 up there is 170. 152 up there is 157. So we have made changes in existing age, height and weight variable where we +2 and +5 for males and females respectively. Alright, now I'll close this. I'll come to the program editor. Now we will learn about else do command. So I'll read this command here. Data admit to semicolon set admit semicolon if sex is equal to capital M, then do semicolon age is equal to age plus 2 semicolon height is equal to height plus 2 semicolon weight is equal to weight plus 2 semicolon n semicolon. Else do semicolon age is equal to age plus 5 semicolon height is equal to height plus 5 semicolon weight is equal to weight plus 5 semicolon n semicolon run semicolon. So now in this command here, I'm looking for the same answer like we did here with this previous command. The only difference here is that I did not write another condition here. I just mentioned else condition. So instead of doing if sex is equal to capital M, I just mentioned else condition because again in the data, apart from capital M, the rest is all capital F. So I did not have to write another condition here. And since I want to do multiple actions together here, so I mentioned a do command because this do command will do all these actions for the rest of the condition, which is if sex is equal to capital F. Semicolon run semicolon. So I'll select this and run. I'll show you the log. So again we'll have 9 variables because we have made changes in the existing variable. We +2 and +5 for males and females in existing age, height and weight variable. Same answer here. Alright, so now we'll close this. Now we will move ahead. Okay, so now if you see here in Explorer, we have just a few libraries here. 5 libraries. But when you're working in an organization, there won't just be only 5 libraries. There will be hundreds and thousands of other libraries. So in SAS, you can create libraries as well. Let's say, for example, all this work that you have done now, you want to save it in a separate library. So we can do that here as well. So this time we will learn how to do this. We'll learn how to create libraries in SAS here. So to do that, we write libname, which is short for library. We give the library name here. Now you can give any name of your library. I've just given an example here, ABC. Otherwise, you can give any name. Now, in order to create a library, you have to paste this part here. So now I'll show you how to do this part. So what we'll do here is we'll open learning materials. What we'll do is we'll create a new folder here. You can create in any folder and you can give any name to your folder. Let's say you give the name ABCD here. You can give any name. So now I'll open this folder. So now you have to copy the part from here. You just single click on top here. This part will be highlighted automatically. You'll right click to copy the part. And now we will paste the part here. Within quotes, we'll have to paste the part, semicolon. Then we write run, semicolon. So now I'll select this and I'll run. So it has created this library ABC here. Now you can save all your work in this ABC library. So that is how you create libraries in SAS. Alright, now in this SAS user library, we have all these data sets here. So now let's say you have joined an organization and the only reason you have joined this organization is because someone who's working there has left the job. So now whatever this person has worked on has saved all of his or her work in this SAS user library, which is all these data sets here. So now you are a new person in this organization. Your manager asks you to open SAS user library. Tell him how many data sets are there. Open each data set. Tell him how many observations and how many variables are there in each data set. So now if you have to start doing that one by one for admit, June, all company data, then that would take you a lot of time and a lot of work here. So in this case, what we'll do is we'll just write a command for that. So now we will learn how to see all SAS files in a library. So to do that, we have to run a proc command. All this while we have been doing data command. Now we will come to proc command here. If I show you results and output window, they are empty. That is because they are not required when we run a data command. They are only activated if we run a proc command. So to see all SAS files in a library, we write proc contents, which means it's a procedural command. I want to see the contents of, you mention the name of the library, dot. Now underscore all underscore is an automatic variable here. Automatic variable starts with an underscore, ends with an underscore. Now by mentioning underscore all underscore, it means that I'm telling SAS that I want to read the contents of all the data sets in whatever library I specify. So that is just an example command here. I'll read this actual command here. Proc contents data is equal to SAS user dot underscore all underscore semicolon run semicolon. So now this is going to give me the contents of all the data sets in this SAS user library. By mentioning underscore all underscore, I don't have to mention each name of the data set that I want to read. It will automatically read all of these, which is in SAS user library. So automatically when I run the proc command, it will automatically take us to listing and HTML. So I already told you that there is no difference between listing and HTML. It has printed the same data. And I told you I'll be teaching you from HTML because it's much easier to read from. So if you see here, this is the contents procedure of library SAS user. If you see, it has read all those data sets. Admit, June, all, company, all these data sets here. Now, if your manager asks you how many data sets are there, you can just tell him there are 43 data sets in this SAS user library. Now, because we mentioned underscore all underscore, so it has read the contents of each data set as well. SAS user.admit. This number of observations here, 21 observations, this number of variables, 9 variables, and all the name of the variables also has come in alphabetical order. Height, ID, name, sex, weight. Now it's giving you the contents of admit June data, which is the second one. This number of observations, this number of variables, and all the name of the variables here have come. Now it's giving you of all data. Now it's giving you of company data, all companies. So now it has given you the contents of each data set, and that is what we want to know: number of observations and number of variables in each data set. So we got to know all of that with a single proc contents command. Alright, so now let's say this time you don't want to see the contents of all these data sets here this time. Let's say here this time you only want to see the contents of a single data set only. Let's say this time you only want to see of admit data. So let's see how do we do that. So I'll write proc contents data is equal to SAS user.admit semicolon run semicolon. So now this is only going to give me the contents of admit data which is in the SAS user library. Earlier I mentioned underscore all underscore, so it has given me of all these data sets. This time I've only mentioned admit, so it will only give me the contents of admit data from SAS user library, the contents procedure of SAS user.admit, and nothing else. So that is proc contents command. Now we will move ahead. Now we will learn how to delete data set in a library. So one way to delete a data in a library is we can just right click on any data and delete that. That is one way. The other way is we write a proc command for that. So we write proc delete data. We mention the name of the library, the name of the data set that we want to delete. That is just an example command. This is the actual command here. Proc delete data is equal to work.admit semicolon run semicolon. Now this time it will only delete admit data which is in the work library. This data which is in the work library. So I'll select this and run. It has deleted admit data from work library. So now we will learn how to do this. How to delete every data in a library. How to delete all these data sets in a library. So to do that, we write proc data sets. We mention the name of the library. We mention this command kill here. Again, this is just an example command. This is the actual command here. So I'll read this. Proc datasets library is equal to work kill semicolon run semicolon. Now this is going to delete all the datasets in this work library. We've mentioned this command kill, so it will delete all the datasets here. I'll select and run. Automatically everything in the work library has been deleted. Now you can mention any name of the library here. I've just mentioned work library because I do not want to delete anything from the permanent libraries here. And anyways, in the work library, once we close it, anything that we store here is deleted automatically. So that's why I've just used work library as an example. And that is it for your day 2 codes as well. Now I'll just show you what all has to be done. So after day 1 class, you had been reading all of this. Now if you go read all of this again, you'll be able to understand better because we have practically worked on this. After that, what you can do is you can open codes, SAS training, basic, open day 1, day 2 codes. Just like how we did earlier, you'll Control A to copy all these codes and paste them in the program editor again. You'll paste in the program editor just like how we did earlier, Control V. So this is how we recommend you practice. What you'll do after every command, you'll leave some decent space and then you start typing the command on your own here. Because if you type the command, you'll be paying attention where to create this data, where to pick up this data from. So naturally by typing it, you'll be able to remember and learn the codes faster. After you type the command, you run the command that you've typed, check the log windows for errors and all that. And still, eventually if it doesn't work, you make sure it is the same as the one that we've given you. Because if you see, if I remove just a semicolon from here also, it will not work. It will give us an error. So that is one way you can practice to remember and learn the codes faster. After that, you'll come to assignments. You'll practice 1 assignments. All these assignments are based on what we learn in today's class. So you can try them out. If you're not able to do it, no problem. You can come to the answers folder, check one assignment answers here. All the assignment answers are here. And then finally, you can do this. Read after day 2 class. This is going to give you a gist of what we're going to do in the next class. And that is all for this day 2 class. Thank you.